Let's talk about volume. We'll start by looking at a textbook. A textbook is made up of these individual pages, which have some arbitrary area to them. And what we could go ahead and do is then stack or accumulate a bunch of these pieces of paper and create the full textbook width. So in this case, the same as what we just did with area, where we accumulated some rectangles where we had their area. So what we could do is we could find the area of each rectangular piece of paper and then scale it by the width of the book, and that should produce the overall volume of this textbook. Putting this into an equation, we see that the volume would be the integral of area. So we're going to accumulate or add up all of the individual pieces of area across some region, and that should produce the overall volume of the shape I want. It's important to note that this area function is going to be dependent on the shape of the thing that you are accumulating. In our textbook case, we were accumulating these rectangular pieces of paper, and so the area would be the area formula for a rectangle. But we could do any other shape, right? We could do areas of a circle, or we could do semicircles, or we could do triangles. We could do a bunch of different shapes. As long as you have an area formula for them, we could go ahead and accumulate those things, okay? This leads us into the two ways in which we find the volume of a region. The first is via cross-sections, and the second is via revolution. In the case of cross-sections, what we would do is we would take the region that we want and we would slice it using a specific shape. So in our case with the textbook, we would have a slice that was a rectangle, and we would add up all of those slices over the region to produce the full shape. That's what we would do with cross-sections. But with revolutions, it's a little bit different because we can actually produce different shapes depending on how we rotate. We essentially have three options. We can either revolve using a disc, a washer, or a shell. For a disc, we simply have a circle with some radius little r, and therefore the area formula would be pi r squared. In the case of a washer, which is like a donut, the inside ring or the inside circle is missing. It's been removed or deleted, and so we only care about this outer ring. Therefore, the area of the outer ring that I want would be the area of the large circle in its entirety, pi capital R squared, minus we would go ahead and delete the inner circle's area, which would be pi little r squared. And we might pull out the pi from both terms here to end up with pi times big radius squared minus small radius squared. And with the shells, we have some cylindrical shape, which has some radius r and some height h, and the area of this is actually just going to be the surface area, which is 2 pi r h. Nonetheless, whatever method is used to find the volume, it all comes down to this simple formula that the volume is equal to the integral of the area function.